We're going to now have a look at circles and semicircles. But before we do that, let's have a look at what we already know so we can connect what we already know to our new theory. So we know that general functions and formulas can have an equation of y equals a outside of x minus h to some power plus k. And when we have a look at that, we know that the letters A, H, and K all stand for something. So A is something to do with the dilation, and the dilation is in the up and down direction. H and K form the coordinates of some important point, or they form asymptotes where x equals h and y equals k. And our letter N is the letter that determines the shape of the function. Let's have a look at a few examples before we move on. Now, so far we've really looked at three different graphs, and I'll do them each here. The first one is the hyperbola. And the hyperbola has an equation of y equals a over x minus h plus k, or in the standard form, a outside of x minus h to the -1. That's the important power that tells us the shape, plus k. And a hyperbola will look something like this. You're going to have your asymptotes, as I said, at the lines h and k. So if we get an asymptote here, this might be my x asymptote because it's where x is a certain value always, and this might be my y asymptote. So the equations of my two asymptotes will be that x equals h and y equals k. My dilation factor will tell me how much I've stretched it in the up and down direction, in the vertical direction, and the -1 tells me the shape looks like that. So there is my hyperbola with standard form and my axes, or my asymptotes, shown in. The next graph that we know is our truncus. And the truncus has the equation y equals a over x minus h squared plus k, or in the standard form, a bracket x minus h to the power of -2 plus k. And what that means, the -2 tells us that it's the truncus shape. And a truncus, in a similar way, will have its asymptotes wherever h and k are. Let's put one here for no apparent reason, and one here just because that's not where they were in the last example. And I'll just try and get that straight, but it's not going to work. And now I'll draw in my truncus, and the truncus looks like this. It's like a tree trunk. Now, if you have a look here, that's not very good because it shows that the line isn't always approaching my asymptote. If you found this video helpful, please subscribe to my channel or like the video.